All right, guys, so before we get started today, are there any questions over any of the assignments thus far? Any question over any of the homework assignments so far? If there's no questions over any of the homework assignment, what we're going to be doing today is continuing solving exponential equations. Now, what we did yesterday, if we can get the bases to be the same, then the exponents are equal to each other as well. Well, here, is there any way I can rewrite 7 as 2 to a power? No, because 2 squared is 4, 2 cubed is 8, so there's no way we can do this here. So now we have to use logarithms to be able to solve this. Now, one of the first things we need to do is get whatever the number with the exponent variable and the exponent by itself first. Well, in this case, it is by itself. After we do that, we can apply log with a certain base to both sides. And we'll do this specifically if we only have one variable in an exponent. Now for this here, I'm going to apply not just any log, but a specific log to both sides. And that's going to be log base 2. We're going to apply log base 2 to both sides. Now one of the nice things with applying log to both sides is that our exponent property states that we can move the exponent to the front. Telling us that we have x times log base 2 of 2 is equal to log base 2 of 7. Any questions on anything we've done so far? Now there is a reason that we applied log base 2 to both sides. Now on the left-hand side we have x times log base 2 of 2. What is log base 2 of 2? You got it the first time. What is log base 2 of 2? Log base 2 of 2 is 1. Logarithm. So really what we have is x times 1, which is just going to be x. One of the properties we had the other day is that log base b of b is 1. Whenever the base and what's inside the logarithm are the same, it reduces to 1. It is an exponential form. If we did change this to exponential form, we'd have b to the first is equal to b. It simplifies to 1. So by applying log base 2 to both sides, we're able to, 1, get the variable out of the exponent and reduce this side to just 1 times x, or x. Yeah, so it's based off the number that we have with the variable. Now at this point here, we just need to evaluate log base 2 of 7. Now there's two ways to do it. One, we can go in the graphing calculator, math, log base 2 of 7, which is this here. We'll round to the third decimal place, so 2.807. And get this here. The other way we can do this is with our change of base, which stated that log base b of x is the same as log of x over log of b. So we change it to the common logs, base 10, and we can plug it into the other calculator. So this one here, we can say log of 7 divided by log of 2 is, again, 2.807. So we're able to do it in either one, especially with the change of base formula. Questions on any of this here? We're ready for the next one. 3 to the x is equal to 8. So 3 to the x, that's the only place where you have a variable in the exponent. It's already by itself. So we can apply log of what? Log base 3 to both sides. Notice that let x times log base 3 of 3 is equal to log base 3 of 8. Now log base 3 of 3 will reduce to 1, leaving us with just x is equal to log base 3 of in the graphing calculator, we can do math. Log base 3 of 8 and get 1.893. Now we can do it in the 30xs, but we have to do the change of base, which we say is log of 8. Oh, yeah. Log of 8 over log of 3 and get 1.893. And that's it there. Any questions over any of this here? Now we could try typing this back in to make sure that this works. 3 to the 1.893, and we should get what? We get something close to 8, because is 1.893 the exact value of our answer? No, because our log base 3 of 8 was what? 1.892789261. Continuing on, we had to approximate, so if I plug in the approximation, we should get something close to the answer. We will not get the exact answer. The only way to get the exact answer what we had. Because if I plugged in the graphing calculator 3 to the log base 3 of 8, we would indeed get 8. We'd get 8 back. Questions on any of this here? We good with this here? Let's look at the next one. 7 to the 9x is equal to 15. What do we think the first step should be? Log base what? So the first thing we can do is apply log base 7 to both sides. And if we apply log base 7 to both sides, the 9x will move to the front. So we have 9x times log base 7 of 7 is equal to log base 7 of 15. So even though there are two terms in the exponent, both of them will still move to the front. Questions on this here? Now log base 7 of 7 is what? 1. So this will simplify out, leaving us with 9x is equal to log base 7 of 15. Now up to this point, x is already by itself by the time we get to this point here. And this one here is x by itself. No, we have 9x. So to get x by itself, we would need to divide both sides by 9, telling us x is equal to log base 7 of 15 divided by 9. And with any of these here, and as we've seen to this point, most of the logs that we're going to be dealing with are not going to give us a nice number, a nice decimal. So we'll need to wait on plugging them in. So in the graphing calculator, we can go alpha y equals enter, math, log base 7 of 15, and the whole thing divided by 9. So x is equal to 0.155, approximately. But that's it. Questions on any of this here? So even though we do have more than one term in the exponent, we still solve it the exact same way. It's just after we apply the log to both sides, we have to solve for x. That's it. Questions on any of this here? We're ready for the next one. Well, this one here has a little bit more to it, because this time the exponent is 3x plus 7. We still do the same first step. We do get it by itself, and then apply log base 5 to both sides. Now the exponent will move to the front, giving us 3x plus 7 times log base 5 of 5 is equal to log base 5 of 311. And as we've seen so far, this is just 1. And if we multiply 3x and 7 by 1, we just get 3x plus 7. If it had been something other than 1, we would actually have to distribute it out. But since it did become 1, it reduces the left-hand side to just being 3x plus 7. Any questions on how we got to this point here? Is x by itself? So the first thing we can do in solving for x is subtract 7, telling us that 3x is equal to log base 5 of 311 minus 7. So we wouldn't subtract the 7 from 311 because the 311 is being applied to the log base 5. So those are going to be two separate terms. And lastly, we're going to divide by 3. Telling us x is equal to log base 5 of 311 minus 7 divided by 3. Yes. And that's it. Now, at this point here, we can plug this in. Alpha y equals enter. Math. Log base 5 of, well, 311 minus 7 all over, is it 3? And we get negative 1.1445, or approximately negative 1.145. Any questions over anything we've done thus far? What do we think about most of these here? Pretty good. I say we feel comfortable with these here, yes? Because this here is not any different, it's just different numbers. If we feel good with these here, we're going to move on to this one. Now, this one here, we're going the other way around. This time, well, not the other way around. This time we have a base of e, yes? Now, since we have a base of e, the first thing we want to do is get it by itself. Now, up to this point, the number that had a variable in the exponent was already by itself. We didn't have to do anything to it. Here, we're going to need to get it by itself first. And the first thing we can do is add 7 to both sides. which will tell us that 4e to the negative 0.3x is equal to 20. What can we do next? So 4 and e, how can we get rid of the 4? We can divide both sides by 4. And if we divide both sides by 4, we get e to the negative 0.3x is equal to 5. Is e by itself? What logarithm has a base of e? So if we apply ln to both sides, on the left-hand side, just like before, the negative 0.3x will move to the front. And it's being multiplied by ln of e is equal to the natural log of 5. Now, what is the natural log of e? It is indeed 1. Kind of a funny way that I think of it is, it is 1. ln of e is 1. Because the base and what's inside it are the same. So that's really going to simplify out, leaving us with negative 0.3x is equal to the natural log of 5. And yes, at this point here, the variable is out of the exponent, but it's not by itself. So we need to divide both sides by 0.3x, by negative 0.3x, not negative 0.3x, just negative 0.3. Because we need x by itself is equal to the natural log of 5 divided by negative 0.3. And at this point here, we plug it in to get negative 5.365. And we get this here. So this here isn't any different than what we've done before, except instead of using log, we're using the natural log. Because the natural log and logs are essentially the same thing, except that a natural log's base is understood to be e. Any questions on this here? Are we ready for the next one? Three e to the x minus 4 is equal to 8. So the first thing we need to do is get e by itself. So we're going to add 4 to both sides. Minus 3e to the x is equal to 12. Then indeed we would divide by 3, telling us that e to the x is equal to 4. Yes. Now at this point here, we do get e by itself, so we would apply the natural log of both sides. Now we would move the x out front, which leaves us with ln of e, and ln of e is, so we can, x is equal to the natural log of 4. Yes. Because log and ln are normally next to each other. Now the nice thing with log, log, is if it is base 10, we can just use the log button. If it's e, we can just use ln. So ln of 4 is equal to 1.386. And that's also the nice thing with the change of base, where we had before log base 2 of 7 can be rewritten as log of 7 over log of 2. We're just changing the base to 10. We could change the base to e if we wanted to, but then we just say ln of 7 over ln of 2 and get the exact same value. Any questions over any of these here? Do we feel comfortable with these here? Okay. This brings us to the last type of problem that we're going to look at today, and that's this here. Now, just like we started off the lesson with, that log base b of b is 1, we have another one that we had with these inverse properties, and that was b to the log base b of x, and this here was equal to x. And we can use that property with solving, because if I'm given this first one here, log base 2 of 5x minus 17 is equal to 3, well, I can put both sides to a base. But what base would I use? 2, because 2 to the log base 2 of 5x minus 17, well, according to this property here, b to the log base b, if we have this, then it's just going to simplify to what's inside the parentheses. So for this here, we do have this match, so it should simplify to 5x minus 17. But if I do something to one side, we have to do it to the other, which will tell us that 5x minus 17 is equal to 2 to the third. And up to this point, whenever we applied the first step today, the number that we got from it was not a nice number. Because for the first one, we ended up with log base 2 of 7. That's not a nice number. Is 2 to the third a nice number? Yeah. There it is. 8. So really we're saying 5x minus 17 is equal to 8. Then we just need to solve for x, so we can add 17 to both sides. Telling us that 5x is equal to, and last but not least, we can divide both sides by 5. X is, and that's it. Now we can check and make sure. The one thing we need to make sure is, one, that it does work, but two, that what's inside these parentheses is not negative or 0. We cannot take log of 0 or a negative number. And if we did type it back in, log base 2 of 5 times 5 minus 17. Well, 5 times 5 is 25. And 25 minus 17 is 8, and that will indeed give us 3. Because if we'd gotten negative 8, that doesn't work. We cannot have a negative inside the logarithms. Any questions on this here? So let's look at the next one here. We can put both sides to the base of 3. These will cancel, telling us that 10x minus 9 is equal to 3 to the 4th, or 81. We can type 3 to the 4th in a calculator and simplify it. Any questions on this so far? Because really the first main step, applying base 3 to both sides, is really the key piece to this, because after that, we're going back to our multi-step equations. So we would indeed add 9 to both sides. 10x is equal to 90. And x is equal to, now we can have quadratics if we needed to, and if we end up with a quadratic, we can just graph it and solve from there. Are there any questions on this here? Are you ready for the next one? Because here, what would we do? Apply both sides to the base of. And that's it. So you have the rest of the time to work on